Okay, we're going to take a look at solving a particular kind of trig equation. So the equation I want to look at this time is sine of x plus pi over 6 equals sine of x minus pi over 4. So looking at this, it seems like a good place to start, since we've got sine of a sum and sine of a difference is the sum and difference formulas for sine. So I'm going to go ahead and write that at the top here. I'm going to write them as 1 using plus or minus. Sine of alpha plus or minus beta is sine of alpha cosine of beta plus or minus cosine of alpha sine of beta. Okay. So I am going to try using these two formulas, the sum on this side, the difference on this side, and see if anything useful emerges. So following this pattern, I get the left-hand side becomes sine of x cosine pi over 6 plus cosine of x sine of pi over 6. And the right-hand side becomes sine of x cosine of pi over 4 minus cosine of x sine of pi over 4. Okay, so several of our terms, all of our terms have a factor that can be evaluated. So let's go ahead and evaluate the cosines of these angles. So this becomes cosine of pi over 6, we know is root 3 over 2. I'm just going to move it to the front as a coefficient. So root 3 over 2 sine of x plus we get 1/2 cosine of x. Sine of pi over 6 is 1/2. Cosine of pi over 4 is root 2 over 2 sine of x minus root 2 over 2 cosine of x. So now there's still a lot going on. I'm going to see what else can happen. I'm going to start combining like terms. So I'm going to take all the cosines to the left-hand side. And I'll take the sines to the other side. All right, so these will cancel and these will cancel. What we're left with over here on the left side is 1/2 cosine of x plus root 2 over 2 cosine x, and I can just factor out those coefficients. And I can do the same thing over here. I get root 2 over 2 minus root 3 over 2 sine of x. Okay, and both of these I can write in a little bit more pleasing, so I'm going to go pleasing of a way, so I'm going to go ahead and do that. Just combining these fractions. Okay, and I can actually just multiply both sides by 2. I could have done that before, but so now I have something that looks like this. Okay, so we still have an issue, right? We've got x and it's locked up in a sine over here and a cosine over here, and the trick here is to recognize that if I take both sides, I'm going to divide both sides by cosine of x, and at the same time I'm going to divide by this coefficient over here. We'll see why in just a second. So the cosines will cancel over here. This value will cancel over there. And so on this side, I get this ugly fraction, 1 plus the square root of 2 over root 2 minus root 3. And on the other side, I end up with sine of x over cosine of x, which is tangent of x. Okay? Oh, sorry, I wanted to put in one more thing. We're going to solve this for our values between pi over 2 and negative pi over 2. We know that there are often infinite solutions for these kinds of formulas, but I'm just going to look in this region. So, in any event, we've got tangent of x equal to some number, and as far as I can tell, I haven't figured out a way to manipulate this into something familiar. Maybe it is, and there's a way that you can work it out. But we've got tangent of x equal to some number. We can undo that using the inverse tangent. Right? So I'll take the inverse tangent of both sides. And over here, we're just left with x. Part of the reason for that is we know that inverse tangent gives us angles between root 2 and negative pi over 2 and pi over 2, which is where we're looking for x. So the result is going to be the x we were looking for. If we had wanted it in another region, we would have to take the result of this and use our unit circle understanding or our graph understanding to figure out where another place where that outside of this region where we have intersections. But for us, we're just looking for this. And so this, I just went to a calculator. This number was negative 1.4, let's just say 399. It goes on forever, so this is just an approximation. Okay. This little trick that we pulled in the middle, getting from this line to this, where we divided both sides by cosine, is a nice trick. There's not another way that I know, another easy way to, when you've got x in these two different trig functions, to undo them, except to combine them into a single trig function of tangent of x, which we know how to invert, or at least our calculator knows how to do the inverse if it's not familiar.